Okay, today we're going to look at another type of stoichiometry problem. If we go back to what we already know, we know first step in stoichiometry problems is to start with the balanced equation. You have to determine what's given and what you're trying to find, or we call that the want. We need to look at our mole ratio, which comes from the coefficients. And we have to have our conversion factors, which we have three of them. 1 mole is equal to the molar mass, the mass in the periodic table. 1 mole is 22.4 liters at STP, and 1 mole is 6.02 times 10 to the 23rd particles. And with these conversions, we're either converting to moles or we're converting out of moles. And we also have to look at our mole ratio, and then we're going to solve. So let's go back to a problem that we've already done. Here's our balanced equation, already done for you. 2H2 plus the O2 will yield 2 H2Os. So we're starting, this is our given, 2.5 moles of O2. We're trying to find grams of H2. So that's our given and our want. Our mole ratio is going to be the 1 mole of O2 to 2 moles of H2. So we're going to write down our given. 2.5 moles O2. We know that if moles is on the top of O2, moles has to come down to the bottom. And this is where our mole ratio is going to be. It's the only way to get from one substance to another substance. In this case, from the O2 to the H2. So we have 1 mole of O2. We have 2 moles of H2. But we're not looking for moles. We're actually looking for grams. So we have to convert out of moles. And our conversion from moles to grams. So we have 1 mole on the bottom. That'll cancel out the units. We're looking for grams of H2. So we have to look at the periodic table. And that's going to be 2.0. Because it's 2 times the 1.0 from the periodic table. We're going to multiply the top. 2.5 times 2 times 2. And you should get 10 grams of H2 on your calculator. You can check your work, make sure that all of your units cancel, except for what you were trying to find, in this case, grams of H2. So that's a mole to gram problem, or mole to mass. If we look at our second example, we have grams and grams, so it's a little bit different. You have to add an extra step. So this again is what we're starting with, and we're trying to find grams of H2. But we're starting with grams this time. So we have to write down our given. We first have to get out of grams, so that's why I said convert out, or convert to moles right here if needed. So we have to convert to the moles first. Grams of O2, again, going to look on the periodic table. There's 2 oxygens, so we did 2 times the 16.0 grams on the periodic table. Gives me the 32 grams of O2. That is equal to 1 mole of O2. Now I've got to convert from oxygen to hydrogen using the mole ratio again. You're always going to have whatever was given to you, the coefficient from your given on the bottom. In this case, it's a 1. 1 mole of O2. What you're trying to go to is going to be the mole on the top. In this case, hydrogen. But again, we're looking for grams, so we have to convert out of moles into grams. So 1 mole on the bottom of H2 to 2.0 grams of H2 on the top. Make sure all of your units cancel out. Grams, grams, moles, moles. Again, moles of H2, moles of H2. We're left with the grams of H2. You're going to multiply everything on the top, divide by your product at the bottom, in this case just the 32, and you should get 3.13 grams of H2. We had 3 significant figures here because we started with 3 significant figures. But make sure you can cancel out all of your units and you end with whatever you circled at the beginning. And that's mass to mass problems.